In this video, we're going to look closely at the MicroETR tool that's available in all probes that have one or more ETR engines licensed. The MicroETR is a patented tool that enables a large volume of ET290 data to be seen at a glance. All ET290 Priority 1, 2 and 3 errors are displayed, along with some selected other checks added by BridgeTech. It's possible in a single view to see errors like missing or unreferenced PIDs, PCR errors and PSI-SI table errors across multiple transport streams. I'm going to select an IP probe to start with. Clicking on the ETR290 tabs shows the main overview screen. Here you can see a large number of MicroETR displays. On this probe they're divided into 4 columns. The number of columns indicates how many ETR290 engines are licensed. And on this particular probe we have 4. Clicking the About and License tabs confirms this. 4 out of a possible 4 ETR engines are licensed. Back in the main ETR290 summary screen, Ethernet 1 equates to ETR engine 1, Ethernet 2 to ETR engine 2, and so on. We'll look at this arrangement in more detail later, but for now let's look in detail at what the MicroETR display is showing us. The MicroETR display is simply a way of presenting a lot of data dynamically and in a small space. You can see that it's divided into 5 columns. Column 1 displays the most serious ETR290 Priority 1 checks. They range from TS sync to missing PID at the bottom of column 1. Column 2 represents the less serious ETR290 Priority 2 checks, starting with transport errors at the top to CAT errors at the bottom. Similarly, column 3 shows errors ranging from NIT to TDT. Column 4 is different in that it doesn't display any ETR errors, but instead some additional tests added by BridgeTech. These range from CA system checks through PID and service checks. The final column shows interface checks, and the data shown here depends upon the interface being checked. In this example, we're showing the interface of a DVB-T transport stream. You can see the checks are specific to this interface type. The colour of the specific rectangles indicates the condition of a particular test. Green indicates a test which has been passed. Red indicates a test which has failed. Grey indicates a test which is ignored and therefore masked, and white indicates a check that is currently pending or in progress. If you look at the leftmost column labelled Ethernet 1, you can see there are 6 multicast streams sharing ETR engine 1. Engine 2 has 4, 3 has 8, and ETR engine 4 has 5 streams. Multicasts are assigned to individual ETR engines in the Ethernet tab, and we'll look at that later. The round clock face indicates the stream that is currently being tested and its progress. This sharing of ETR engines by the multicast streams is called round-robin testing. Let's have a look in more detail at how round-robin analysis works. In this example, we have 4 multicast streams sharing an ETR engine. You can see that service 1, NRK, is currently being tested. The clock in the centre represents the user-defined time that the service spends being tested. When the time slot is completed, the services shuffle round and testing begins again on service 2. Then service 3 gets its turn, And finally, service 4 enters the ETR engine. This process is repeated as long as the probe remains powered. It's easy to see, therefore, that the more services that share an ETR engine, the less time they spend being tested. Let's have a look now at how we configure which multicast stream is tested by which ETR engine. This is done in the Ethernet and Multicast tab. Let's look more closely at the ETR, engine and join columns. A stream must be joined before it can be tested by any ETR engine. A tick in the ETR column indicates that this stream, if joined, will be tested. The engine column indicates which of the 4 engines on this probe is assigned to this task. Remember that by clicking any of the column headers we can sort on that particular column. Let's see how to change the ETR engine assigned to any particular stream. I'm going to pick the NRK1 stream. Click Edit and then click the ETR tab. It's then as simple as selecting the ETR engine from the pull down. Remember to click Apply Changes. This change to ETR engine 4 is immediately shown in the engine column. Going back to the ETR290 overview, you can see that NRK1 is now appearing in the ETR engine 4 column. Let me return it to its original condition. Notice the MicroETR will remain white until it's turned through the ETR engine. Returning to the main ETR overview screen, I can lock any service into its ETR engine by clicking in the lock column. This produces a padlock icon showing the service is locked. Clicking the padlock will unlock it again. It's possible to limit the amount of time any user is able to lock a stream in an ETR engine in the Setup tab. If I move my mouse pointer over the MicroETR display, a tooltip indicates individual ETR290 checks. Clicking on the MicroETR display will bring up the main ETR Details tab, and we can see much more information about the individual checks. The structure of the MicroETR display is carried over to this larger display. You can see that even though a particular test is ignored and shown in grey, this doesn't stop the ETR engine from registering errors. They just don't register any alarms. Clicking on any of the checks will pop up a detailed alarm log. If we now have a look at a VB330 10 gig probe, we can see that it has a bulk ETR option. Checking the licenses on this probe shows that 50 out of a possible 200 ETR engines are licensed. If all 200 ETR engines are licensed, this would enable the probe to test 200 transport streams concurrently. On a VB330, the lock column shows which ETR engine is testing which stream. You can see that this probe has multiple streams per engine. In other words, even though this probe has 50 ETR engines licensed, it has still been configured to do round-robin ETR testing. Let's see how this display changes when one engine is configured to test one stream. We'll change the last 2 streams on this page. Go to Ethernets and Multicasts. I'll edit the AirRang stream and change it to ETR engine 14. And for ZDF I'll do the same, but change it to 15. Going back to the overview page, we can now see that Erang and ZDF have their own engines, and the lock column has changed to a circular icon indicating that this stream is being continuously tested. Once the clock faces complete their cycle, they will not change. Looking at an RF probe, we can see that each RF input has a single ETR engine. As with the IP multicast streams, COFDM muxes can be cycled through a single ETR engine as the demodulator retunes. Notice how COFDM inputs 2 and 3 have only a single frequency configured, and that the display also shows a full clock face and the circular continuous icon. Finally, let's see how ETR engine licensing works across the probe range. The VB1 and 2 series probes can all be licensed with between 0 and 4 ETR engines. All of the VB1 and 2 series probes have an ASI input built in, and this has a single ETR engine. All of the RF interface cards have 1 or 2 inputs. Each of its inputs has its own ETR engine. The VB242 ASI probe has 2 ETR engines. And the VB330 10GB probe may be licensed for up to 200 ETR engines. We hope you found this video interesting and useful. Be sure to check out the others in the series. If you've got any ideas for videos you'd like to see, email us with your suggestion. Bridge Technologies offers a full 2-day technical training course covering all aspects of probe and VBC operation, as well as a theoretical background. Training can take place in our purpose-built training centre at our Oslo HQ, or it can be delivered at your own premises. If you want to contact us, visit our website or email us at training@bridgetech.tv.